this video we're going to fix our mouse. As you saw in the previous video, we could not really point at the extremes of the screen. And this is because the way we are calculating our current position. We are using a rather naive method, as you call it. We are effectively creating a large circle around the camera and then simply setting the x-coordinate to 0, which works for some cases but not for all. Let me demonstrate again what's going on. I create a sphere and then I am going to make it larger, and what we were doing is when we're pointing to any location on the screen, on the circle, we are taking that point and then simply setting it to this plane over here. But you can imagine that when we get to the sides of the circle, when we would extend the line further, we would be going like this, but we are actually just setting the x-coordinate to 0, so we are going straight forward. So I'm going to delete the circle again. We are going to recreate our mouse pointing mechanism using raycasting, and we are going to do this by creating collision channels, and we have already worked a little with those. I'll show you what a collision channel is. So this collision on the base of the ABM is currently set to default. I will change it to pawn, and then I'll expand all the collision properties. So as you can see, there are a number of properties here, like collision enabled. So this toggles whether we collide at all. Some objects would not collide at all with anything else, and you would disable this to reduce CPU load. And at the bottom here, you can see all the other object types and what our response to colliding with those object types would be. For example, here is a visibility collision, which would be ignored. But when we go to another pawn, we would block the other pawn from moving into us. And it's also possible to only create an overlap collision, like we've done with the ICBM. But we are going to create our own collision preset for a special mouse collision box, and then we are going to use raycasting to find where on that box we are pointing. So let's start over here by creating a new box collision component. And I will just add it to drop it into the root, attach, and I will go create a large, really large collision shape and a very wide one. And maybe there are other ways to solve this issue, but this is the one I'm using right now, also to show you raycasting techniques. And it can become very thin, really as thin as possible. Let's see what the scale is. It's set to 0. I'll make it 0.01. So it's really just a millimeter thick. And now we will create our own custom channel that will only collide with the raycasting we are going to do using the mouse. So we go back to the main window, we go to Settings, Project Settings, and then we are going to go to the Engine tab and click on Collision. And I'll just expand this one. Here you see all the collision presets there are. We could select in the Blueprint editor, and we are going to create our own custom object channel and our own custom trace channel. And the object channel is simply a way to define how our object is going to interact with all other objects. And I'm going to call this mouse plane. And the default response would be to simply ignore the other objects, because we don't want any objects to collide with our mouse plane. And then I am going to create a new trace channel, which will be called mouse plane trace channel. And the default response would be to ignore. Because when we are going to raycast, we are going to select this trace channel, and we don't want it to collide with anything except for our mouse plane. Then for the last part, we are going to create the mouse plane preset. And in the preset, we can edit all the response types to the various object types and trace channels. And here you see the mouse plane trace channel we have just created. And here is the mouse plane object type we've just created. So I'm going to call this the mouse plane preset. It will have collision, but only query. So we're only going to query the world and not interact with the world in any way. So the object type would become our mouse plane we've just created. And the description could be something like the mouse plane is used to determine the location in the world we are pointing at. So the default response to everything would be ignore. And we are only going to block the mouse plane trace channel and the mouse plane itself. So accept. So we've just set up the collision channels, and now we're going to modify our getMouseWorldLocation function to raycast and determine the mouse world location in a proper way. So I'm just going to go a little to the side so I have space to work, and I'm going to search for raycast, and we are going to use line trace for line trace by channel. And this is effectively raycasting, and line trace is just another name for it. I'm using the wrong words actually, sorry. We're going to line trace by channel. Let's see, for the start and the end, we already sort of know what we're wanting to do. So let's just copy and paste this code over here, because we were using this to determine where about we are at the circle. And now I want to split this, recombine, sorry. This will be the end, and this will be the start. So let me show again what we're doing. Let me create a sphere. Actually we can create a sphere collision, because then it will be transparent and we can see actually what's happening. So what we were doing before is we were creating a very large circle and then simply cutting off that circle to this plane. But now we are creating a plane and a circle, and the circle will be very large, and we are going to look where this circle intersects with the plane. So I'm going to delete this again. I'll make another visualization later using the debug tools. The trace channel would be the mouse plane trace channel, and we need to untick ignore self because we want to collide with the box collision we've created on this very same actor. So I'll just copy this. Well, that didn't really work. Of course I need to, there can be only one start. I can't copy the start, can duplicate it. And the return node would be recombined. And in the out hit, there should be, when I split it all open, the actual location. And I want to set the debug type for duration, because then I can see what's going on. Now, I've just created this line trace by channel. And that means that this function has an execution line and cannot be a pure function anymore. But let me just press play. Nothing is happening. I'll untick the pure, and now it won't compile again, because now we need to have the execution flow in the function. There and there. Let's make a little more room. And this is going to become a little ugly with all these lines going everywhere, but well, that's the thing with blueprints. They are great to prototype stuff, but when things get complex, it's well, another story. So let's press play, and nothing is happening. Of course, I forgot to set the box to our mouse plane. So with that fixed, it's doing something, but not, well, weird. Let's see, is the box set up? It looks set up properly. Oh, right. I forgot to increase this. We are creating using the spring arm length, so the circle will only extend up to here and not all the way to there. So this is something I forgot to change. I will just get rid of the target arm length and set this to like a big number, like 10,000 or something. That's fine. Let's click play, and now that's looking good. We can shoot everywhere, and when I eject and look quickly, you can see the raycasting results. Process again, eject. It looks pretty awesome, don't you think? Well, that concludes this lesson, and I hope that you've picked up a thing or two about raycasting. See you in the next one.